Okay, ready. Slightly reduce it. Slightly I can make lesser. Okay, 1 minute. Let's see that all visible. Turn slightly. Slight movement. Okay. That 12 carat not visible. Okay, manageable. Solution 1. Solution. Change it. Visible. Solution 1. The pen, other pen. Where I kept it. Black color. Where I kept the black color one. Somewhere here. Get a minute. Okay, we'll manage. This is blue color. Just a minute. This place is being filled. I made many pens ready, but I don't know where I kept it. Not here. Okay. Somewhere. It's not touching or it won't come. Right time not getting it. Usual problem. Where I kept. These are unfilled. Horrible. Okay. Just past, comment past. Today actually I had some little work. Otherwise I told, even from tomorrow also, always correct, join at 7:30 only. Because the work was there, I am helpless. Because 9 I have to close. Voice fully clear? Voice okay? Okay, start. Remember, make a note. We are starting cantilevers now. I will first tell little about cantilever. Not too much why. When in the SFD BMD chapter everything is told, but still make a note. First make a note for cantilever before you start the question. Note. See, cantilever can be either like this or it can be like this. One of them is fixed, other is free. Okay, here A and B. Here A and B. Apply any general loading. Remember, I told general loading. Suppose you apply some couples. What will happen is deflected curve shape will change. That is special cases. Write general loading. See. Now, how is the elastic curve? See. This is fixed end here. This is the initial position. See, here also. This is the initial position. When you apply loading here, cantilever beam will hog. See, it won't bend this way. That actually common sense. People are knowing it. Why waste time? See, cantilever will bend like this. So, elastic curve will go this way. Now, here, elastic curve will go this way. Therefore, if this is A, this is B, see. Now, here at the free end, your Y will be maximum. In case of simply support beam, not that way. See, simply support beam, Y0, again Y0 here, then Y will keep on increasing, reach maximum, again decrease, and support, slope will be maximum. Already over here. Here see, your Y will be maximum here. Here also, your Y will be maximum here. So, under normal case, you can tell Y will be maximum, tell me, at which end? Don't tell AB. Do not tell AB like that. Tell where? Y will be maximum at where? First. Y will be maximum at. Do not tell AB like that. Don't by heart A, B, C, D at the free end. See, Y will be maximum at free end. Free end. That is, here your Y max will be Y at B. Here Y max will be Y at A, or general at the free end. See, next. Here your Y equal to 0. See, Y0. Y will keep on increasing. Maximum here. Then, if I draw tangent here to elastic curve, see, this is the theta maximum. Theta, here also, this will be clockwise here. If I draw tangent here, this will be your theta maximum. So, your theta maximum here, theta maximum will be at B. Here, theta maximum will be at A, or even theta also maximum, tell where? Once again, in simply support beams, theta max at supports, Y max near center. In cantilever, both Y max and theta max will be where? Both are maximum at where? Both are maximum at free end. At free end. Therefore, for cantilever beam, deflection maximum and slope maximum both will be at free end. I won't tell once again. Clear now? Both are maximum at the free end. Clear or not? Under normal load case, clear? Both are maximum at the free end. You are clear? Okay. Therefore, when you want Y maximum, you don't have to struggle like simply support beam. Locate the point where slope is 0, etc. not required. Directly free end. Now, one condition over. Next. At the fixed end, 1 minute now, before going further, when you integrate 2 times, first time you get C1, second time you get C1x and C2. So, you need C1 and C2 calculation. For that, you require boundary conditions. Boundary conditions. See, boundary conditions means what? Where 0 slope or 0 deflection is there. Okay, now, in simply support beam, see, there are 2 unknowns here, C1 and C2. So, 2 boundary conditions are required. In simply support beam or with overhang, conditions are at the support, see, Y at both supports equal to 0. So, if I call this AB, you can tell deflection at A equal to 0, deflection at B equal to 0. Clear or not? Your both boundary conditions are deflection conditions. Clear? In simply support beam or simply support beam with overhang, your both boundary conditions are deflection conditions. Okay, but in cantilever, see, here your Y equal to 0, and apart from that one, see here, if I draw a tangent here, see, slope will reduce. Or when you come to fixed end here, tell me what is slope at A, what is the slope here? Tell me what is the slope at the fixed end. See, if I draw tangent here, it will be like this. What is slope at the fixed end? 0. Or here also, see here theta and y0 at A. Here theta 0 and y0 at B. Or instead of remembering AB, it is wrong. Don't by heart AB. Directly you tell what? While finding constants of integration C1 and C2, we need two boundary conditions. Right? Once again, boundary conditions. In case of simply supported beam or simply supported with overhangs, both the boundary conditions are deflection conditions. Which one? At both the supports, deflection 0. But for cantilever, the two boundary conditions are, one of them is theta, other is y. Or you can tell theta and y both 0 at which end? Tell me, which end? Only one word. Do not tell AB. Both 0 at fixed end. Both are 0 at fixed end. Therefore, make a note. When you find constant of integration C1 and C2, once use slope condition, then use deflection condition. That is, slope and deflection both are 0 at the fixed end. Both are maximum at the free end. Clear? Fast. If clear, I will start the example now. Some more notes are there. If fully clear, I will proceed further. If this is fully clear, proceed further. First, I will do master question. If concept is fully clear, I will proceed further. Later, should not ask. Okay, now further. Simply supported beam, you once again make a note. There is a reaction here, vertical reaction here, vertical reaction there. You have to find vertical reactions. Why? Tell me. Because if I take section XX this side and look that side, that reaction will come. Or if I take a section this side, X from that side origin, that reaction will come. So without support reaction calculation, you cannot proceed further in simply support beam. Right? But then write the statement. But first you should write, in case of simply support beam, support reaction calculation is must. But in case, this I told in SFD BMD, in case of cantilever, support reactions in simply support beam, one vertical reaction that side, one this side. No, in cantilever, where fixed end is there, see, you write one more note, where fixed support is there, there will be a vertical reaction and reacting moment. See, load is down, reaction up. Load will rotate clockwise, reaction anti-clockwise. If it is A, VA and MA. Whereas here, vertical reaction VB and this will rotate like this, balancing this way MB. So at the fixed support, there will be two reactions. Horizontal reaction you are not considering. One vertical reaction, one reacting moment. Now, make a note. There are two options for you. When you consider origin, you can select either left extreme end, don't tell fixed end, or right extreme end. Then decide. Suppose this is the cantilever. See, if I take origin left end, you make every note. After the class is over, write everything. If I take left extreme end origin and section here, somewhere here, at X here, when you look this side, you require reactions. Whereas, by chance, see, R, right here. So here, reactions are RR. RR means reaction required. Whereas, make a note. This is what? If I take A origin, if I take right extreme and B origin, take a section here, at X from here, when you look that side, tell me, is the reaction required? for expression for mx? Is the reactions required for expression for mx? First, if I look that side, is the reactions required for expression for mx? No. Therefore, I will put here RNR. RNR. RNR means reactions not required. Or come here. Here, if I take A origin and take a section somewhere here, see XX here, at X from here, when you look this side, then surely reactions are not required. Look this side. But ಆದರೆ if I take B origin and take a section somewhere here, section XX, at X from there, when you look that side, reactions are required. Now don't by heart left and right hand, or you can write in simple words what? Tell me. Cantilevers, simple words. Don't by heart left and right. Cantilevers. Origins can be, see, the origin, don't tell left and right hand, can be either free end or fixed end. Now, if the origin is free end, when you look that side, do you require reactions? Don't by heart left and right. If you take section origin at the free end and look that side, do you need reaction? Reactions are not required. Reactions not required. Whereas if I take fixed end origin, when you look that side, reactions are required. Therefore, usually for cantilever, see one more thing, see the bending is from free end. Therefore, basic concept point of view also, for cantilever, the ideal solution or a systematic solution, I will tell you why. Because this I told you, when you look free end, see the SFBM will keep on getting added up. And therefore, for a cantilever, the most ideal and systematic solution is always which end origin? Tell me. Which end origin? Usually for understanding subject, which is the correct origin for cantilever? You can take anything. Which is the correct origin for this? SFD BMD I told you. Which origin? Don't tell left and right hand. You should not tell left and right hand. Left and right hand danger. You should not use the word left and right hand. Why? I can give. Why left and right hand? It is free end. It is always free end origin is always, it is more systematic. See, when you take free end origin, when you come here, you can see correctly what? SF and BM keeps on increasing. That is the correct concept. If I look left side, this reaction and this VA all, it is actually gives uncomfortable feeling. Therefore, most ideal is free end, and if you take free end origin, remember, reactions are not required. But in case for a reason, in case for some reason you decided fixed end is better, you want to take fixed end origin, no problem. But then if you take fixed end origin, then reactions are required. Therefore, in the beginning only decide which origin you are taking. In the beginning only decide which origin you are taking. Then, right, if you decided to take free end origin, you need not bother about what? You need not bother about which one? If you take free end origin, you need not bother about. Just start solving. If you take free end origin, never bother. Need not bother about what? If you take free end origin, that is if you are looking free end side. Why this much difficulty? Never bother. Directly start solving by what? Macaulay's method. Even for other method also same thing. need not bother about reactions. Directly solve. But if you take fixed end origin, then before you start Macaulay's method or any method, you have to first find support reactions. Support reaction calculation for cantilever so thoroughly explained in the SFD BMD chapter that much common sense should be there for someone who is studying all this. Now clear? Fast. Everything clear? I will start the question. If everything is clear, I will start now. All this you have to write. Okay, start. Now, question I will dictate. Don't worry. See, I already solved the question somewhere in the corner there and wrote all the answer. Why? Because I know there will be shortage of time. So, sometimes you will give different answer. But how I solved? I used a trick. I got lot of tricks for solving. Every value I wrote there, it took me around what? 3-4 minutes. See, for this beam, I want slope and deflection everywhere. All those are scattered. I think you cannot see it. Why? Because I covered it. I covered it because purpose what? At the first question, don't see it. Okay, now, write the question. See, write the question. There is one more thing. I will take a beam of 8 meter. Usually cantilever will be around 2 meter, 3 meter. If I take 2 meter, 3 meter, distance I have to give 1.2, 1.6. No. First question, I do not want the fractions. So little lengthy cantilever. So what? Question. First, you write the question. Question I will dictate in the class. See, I am dictating in the class. See, one more thing. If a question is given that cantilever, simple language given, you can take the cantilever either like this or like this. Unless they specify it. Next class I will take a question where right side is fixed. Okay, leave it now. Question. In this class I am giving which side fixed. A cantilever beam is of length 8 meter. 8 meter. With left side fixed. In the question I am telling, a cantilever beam of length 8 meter has fixed support at the left end. Right is free. It is loaded by UDL of 6 kilonewton per meter for a length of 5 meter starting from where? Starting from free end. See, 6 kN per meter for 5 meter length. Therefore, if you want, this gap will become 3 meter. Calculated, not given. Calculated. Okay, then also there are 3 point loads. One by one. 12 kilonewton at the free end. Second load, 30 kilonewton at 3 meter from free end. That is, UDL is 5 meter somewhere earlier. Last point load, 60 kilonewton at 1.5 meter from fixed end or left end here. Over. Find what? Maximum slope and maximum deflection for the beam. Then also find slope and deflection at all standard points. At all standard points. See, there are 1, 2, 3, 4, 5 standard points here. Naming I will do later. This is a question. And in the question given, take EI equal to I was 50 into 10 to the power 12 Newton millimeter square. This is the question. Question dictated. Can you write? Question dictated. Can you write the question? It is dictated by me. Question. Can you write it later? Not now. After class is over. Can you write the question? Because you should always write. Sketch is not given. Sketch is drawn seeing the question given in words. Okay. Okay, now start. Now, first make a note. Tell me. You are going to solve the question in what unit? kilonewton and meter. Remember, you are going to solve the question with the load in kilonewton, distance in meter. Therefore, right, little later when the time comes, for numerical value of EI, in the question it is given in what? 50 10 to the power 12 Newton millimeter square. So that value should be converted to kilonewton meter square. Then slope will come in radian, deflection will come in meter. Then you can convert it. This also clear? This also I told earlier. This also I told. Clear or not? EI I told 50 10 to the power 12 what? 10 to the power 12 Newton millimeter square. You have to convert to kilonewton meter square. See, later, see I wrote here, note, EI given 50 10 to the power 12 Newton millimeter square. Therefore, this is your problem, not my problem. Right here, this is your problem. Convert into kilonewton meter square, it comes to 50,000. If not able to get, drop the subject. Better not study. These all thoroughly told earlier. Clear? Later, EI value in required unit. Full clear means tell me, I will start now. If EI value fully clear, I will start. Origin later. Is it fully clear? EI value all. Yes, okay. Then, now, see the question there. Decide which is the origin better. Now, actually, you can take either A origin or B origin. Now, right here. If now, name the points A, B. I will call this point as C, this point as D, this point as E. Second time you have to write, not first time. Second time. And write one more thing. Loads are acting down. There will be a vertical reaction here up. Is 1.5. Clear? And this load will rotate in clockwise. There will be a balancing anti-clockwise reaction MA here. Okay. Even if you are not finding reaction, you make a note that reactions are there. Now start solution. Correctly what I am telling you should write. See here. What I am telling you should write. This is the beam. Point load here, UDL here, and point load here, A, B, C, D, E. Suppose I take free and B origin, because I told you better is free, then your section XX should be between the last 2 points, other side, it should be here. XX, at X from here. Now write. Now this is okay. This is free end origin, most popular. Free end origin is the most popular. But, right here, there is one problem. Tell me, what is the problem? I created a problem. There is one problem. What? Tell me. If I take free end B origin, why? Usually free end is the best solution for cantilever. But if I take free end B origin, section XX should be here. Okay, but there is one problem. What? Tell me. There is one condition is not satisfied. What is that one? One important requirement is not satisfied. Section is not passing through UDL. Right here. This XX is not passing through UDL. Therefore, for this question, if you take B origin and take section here at X from there, then you have to extend this UDL up to here and introduce same UDL here in the upward direction and then start solving. Clear? And then only start solving. Clear or not? First, if you want the most popular free end origin, this correction is required. Helpless. Clear or not? This correction is required. Without this correction or this modification, we cannot do anything. Clear? I said the question that way only. Not every question. This question, you are not answering. You are not answering. Clear or not? That extra extension and balancing is required. ಏನು reply ಇಲ್ಲ. Yes, okay. Right. Then right. Or, right. By chance, and one more thing right here. One more note. Since you take free end origin, no need of finding reactions. That is the advantage for you. You need not bother about reactions. See, reactions are there, but don't bother. Okay, over. Next. Or, suppose this is A, this is B, somewhere on point node here, C, D, E. Suppose you take fixed and A origin. Your section should be between the last 2 points here at X from here. And there will be reactions here. Reaction VA and MA. Now, this advantage is that the section has to pass through UDL here, satisfied or not satisfied. Here, tell me. Here, if I take A origin, the condition or requirement of section passing through UDL, section has to pass through UDL, is satisfied. Therefore, that struggling is not required. See, extending and balancing is not required. Right here. So, right, that extra work is not there. But, tell what? But, when you write expression for BM here, this side, you need what? We need what? We need what? When you write expression for MX, then when you look this side, fixed end side, we need what? There is no reaction required. But here, when you look this side, you require what? You need support reactions. Therefore, before starting the solution, first ensure equilibrium and find support reactions. Make this note. Full clear means I will start solution 1 now. If it is full clear, I will start solution 1. If this much is fully clear, I will start solution 1. First. That all note you are right. Okay, clear. Okay, now start. Now we will solve. How we will solve? I told you 2 options. Okay. Solution 1. Taking right extreme end as origin. Right extreme end means free end. I told in the class. See, right extreme end, that is free end, B, as origin. Consider section XX between the last 2 points on the other side, that is between what? A, B, this is C, I'll put later, this is Avalakti. This is C, this is D, this is E. Between the last 2 points on the other side at X from origin B. So your X goes this way, B is the origin. Remember, since your right extreme end is origin, theta is clockwise positive, remember, over. Now, some statement you have to write. See, I am putting zigzag, no place. You should write dictated in class, write it. When you take B origin, section XX between C and A is compulsory. But it is required that it has to pass to UDL. But unfortunately, it is not passing to UDL. You tell 60 kilonewton, you go come later. Therefore, extend this UDL up to here, and then for the extended length, apply same UDL. This is also how much? This also is 6 kilonewton per meter. Now, where is 60 kilonewton? I put it. There, extend the UDL and apply it. The statement you have to write. Okay, now start. Mark everything from what? Where? From free end. Origin. 3, correct. 5. Then see here. This is 8. This is 1.5. That will be 6.5. Lastly 8. Write equation for bending moment here. See, start. Look this side. Support reaction not required. Minus 12 into x. Don't see here. Minus 6 into x is the total UDL into x by 2. You write there. 6 into x is the total UDL into x by 2. You write. Minus 6 into x is the total load into x by 2. That's why 6x square by 2. Minus 30 into x minus 3. Then after 30, see, 1 minute now. UDL between A and C. See, UDL is not there. UDL should come up to here. Ayo. See, up to here, correct? Up to here UDL. Okay, now, see, 12 over, UDL over, 30 over. Don't write 60. If you come from there, after 12, after 6, after 30, before 60, you get the upward UDL. So, plus, why plus? Upward, positive, sagging DM. 6 kilonewton per meter for this is x, this is 5 into x minus 5 is the total load into x minus 5 by 2. That's why I wrote plus very important, 6 into x minus 5 whole square by 2. Already explained. Lastly, minus 60 into x minus 6.5 equal to EI d square y by dx square. Okay, start. Now, as usual, integrate. I use blue color. Integrating, you get EI dy by dx that at the point x. Red color. At the black, madam. That black I don't want now. I will come to the blue color only. It's not right here. At the point x, I told you that is nothing but slope theta at the point x, right side origin in clockwise positive equal to, start, C1 then minus 12 into x becomes x square by 2 minus 30 into x minus 3 becomes x minus 3 whole square by 2. This by 2 will come here, by 2. Then minus, see, oh, I forgot 6 only. Yo. After 12, next is 6. Minus 6 into x square by 2 becomes x cube by 6 minus 30 into x minus 3 becomes x minus 3 whole square by 2, then plus, why plus, see here, plus 6 into, 6 into x minus 5 cube by 6, because why? Because their square by 2 is there, minus 60 into x minus 6.5. 6.5 square by 2. This is going to be your slope equation. Remember, x from origin B. Then integrate once again. EI y at any point x in upward direction equal to C1 into x plus new constant C2 minus 12 into x cube by 6 minus 6 into x power 4 by 24 minus 30 ಕಾಣ್ತಾ ಇದೆಯಲ್ಲ x power 4 by 24 minus 30 into x ಹಿಂಗೆ 30 into x minus 3 whole cube by 6 plus 6 into x minus 5 x minus 5 power 4 by 24 minus 60 into x minus 6.5 cube by 6 is your deflection equation. Now do one thing. Next step. To get constants of integrations C1 and C2. Now, before you proceed further, somewhere outside make a note. Before you proceed further, somewhere outside make a note. Not here. I forgot. So not here. You tell the problem. Hey, you wait for some time. Okay. See, just imagine a cantilever this way. Don't write anything here. Length is L. This is A, this is B. You know that see, dotted line. This is the line. It will bend like this. At B, this is your Y maximum. This is your theta maximum. Whereas theta is 0, Y is 0 here. So both are 0 at A. Both are maximum at B. Don't by heart AB, at free end. Okay, then. Or, right, if the cantilever is like this, elastic curve will come this way. See, this is A and this is B. This is your Y maximum. This is your theta maximum. Both are maximum at A. At B means at free end. Here also free end. And 0 at fixed end. Here theta equal to 0, Y equal to 0. At B that is fixed end. Now, see here. Here, if I take B origin, you make a note here. Write the sketch once again. You write here. Second time you have to write. Same question. If I take B origin, then what happened? Tell me. For boundary conditions, these are the boundary conditions. Your theta A equal to 0. Therefore, theta becomes 0 for x equal to L, and also deflection at A equal to 0. Deflection at A equal to 0 means y becomes 0 for x equal to L. Or same beam, by chance, if you take A, this is B origin. If I take A origin, x this way, then see here. And one more thing, and later, theta max and y max, for both of them, x equal to 0. Okay, here, if I take A origin, same beam, then theta 0 here, y 0 here. So, you can write theta A equal to 0 means your y becomes, theta equal to 0. Theta becomes 0 for x equal to 0, and deflection at A0 means here only origin. Y becomes 0 for x equal to 0. Okay, now, write here, you write, I will explain. If I take what? Free and A origin, then theta and y both are 0 for x equal to L, and both are maximum for x equal to 0. Whereas, if I take not A origin, you write once again, if I take B origin, x this way, then theta and y both are 0 for x equal to 0, and theta and y both are maximum for x equal to L. Or don't see there. Whether cantilever is this way or this way, irrespective of that one. If I take free end origin, 0 theta 0 y is for x equal to L, theta max y max for x equal to 0. Whereas if I take fixed end origin, 0 theta y theta 0 y both for x equal to 0, maximum theta maximum y both for x equal to L. Write correctly. Those who are serious, tell me. Fully clear? I will not repeat again and again now. First of all, this much telling is not required. If it is full clear, I will proceed further now. Fast. Full clear. This question I want to complete today, because why? I cannot write next time. You are not answering. You tell full clear. Then I won't ask questions with you. I won't ask further question. Why? Non-stop calculation. See, just a comment clear means, okay, clear. Okay, start. Now, all this over. See, now, right. Our case, this question I will not remove. Tomorrow also it will be there. Why? Today, FPM class, I will use the board this side. I am not going that side. See, this will be still there tomorrow. Okay, set. Now, C1, C2. Our beam is like this. Our beams here. Elastic curve is here. This is A and our origin, this is B. And remember, our origin, now we are solving the question with free end origin, X goes this way. Therefore, elastic curve will come this way. Remember, I will not tell once again later, this is your Y maximum and this is your theta maximum. But remember, make a note, these are not boundary conditions. These are not boundary. Boundary means what? Zero. So, our boundary conditions are theta A0 and deflection at A0, because, see, simple support cannot move, but it can rotate. Fixed end can neither move nor rotate. Over. Start. Condition number 1. Theta, and remember now, the full length is how much? 8 meter. Our X is this way. See, our X goes this way. Your condition is theta A equal to 0. That is, your theta becomes 0 for X equal to 8 meter. 8 meter. Okay. Substitute in which equation? Bus ticket means bus stand. It is a slope condition. Substitute in slope equation. See, 0 equal to, see, since X is 8 meter, all terms will come. Why? Because every term is positive. So, start. 0 equal to C1 minus 12 into 8 square by 2 minus 6 into 8 cube by 6 minus 30 into 8 minus 3 is plus 5 square by 2 plus 6 into 8 minus 5 is 3 cube by 6 minus 60 into 8 minus 6.5 is plus 1.5 square by 2. Simplify this one and tell me the C1 value. I will take a small break. Okay. You tell me later. Not now. You correctly understand now. Over. Start. Next condition. Deflection at A equal to 0. That is, your Y becomes 0 for, once again, X equal to 8 meter. Now, substitute in deflection equation. 0 equal to C1 into 8 plus C2 minus 12 into 8 cube by 6 minus 6 into 8 power 4 by 24 minus 30 into 8 minus 3 is plus 5 cube by 6 plus 6 into 8 minus 5 is plus 3 power 4 by 24 minus 60 into 1 point plus 1.5 cube by 6. And by this time, your C1 is already calculated. Already calculated. See, already. Therefore, substituting that C1 value here, get me C2 value. Now, correctly type C1 value and C2 value in the comment box. I will come after 5 minutes. Because why? Non-stop talking. I got a class up to 10:30. So, I need little rest. Not too much. Substitute correctly there, get C1. Substitute here. Sign is very important. See, all these numbers should go that side. Simply suppose give C1 comes negative. Here C1 may not come negative. Substitute and tell me C1, C2. Okay. I need at least 3-4 minutes rest actually. Okay. You calculate. I will come in 3-4 minutes. Type C1 and C2, both of them. Okay, I will start. Too much time is not there for break because class is there for me. Nowadays, class up to 10:30. As soon as your class is over, 15 minutes break and again new class. Yesterday I started. So I should be more careful. Should not train too much. Okay, now see correctly. Whatever you do, I am not seeing your comment box. I already got every answer there. Your C1 has to come. Whether you are getting or not getting, no other way. Where I kept the pen all? Here. Your C1 has to come 1 plus 1.5 and C2 has to come minus 7.8 05.5. I calculate because to save the time. Not that I solved the question earlier. I don't require that way. Answer came. Now I am not seeing your comment. Correct answer? C1 1311.5. Okay, correct. Minus 7805.5. Okay, correct. Done. Correct. Okay. Congratulations. So I will remove now all this one. See, therefore you know the value of C1 now. I will complete the question. See, I will tell you what way this week I will take the class. Today I will complete this question full. Then tomorrow I will do the same question by taking fixed end origin. That answer I wrote there, it will be there. Why? FPM class, I need only this much space. This beam will be there. This will change. Day of tomorrow and tomorrow only, I will give extra question for solving for with the answer. That is, I will put UDL this side and point load this side. Then this origin means you need extension. Ulta. Answer I will give. That is tomorrow question. Tomorrow is Wednesday. Thursday I will go for all standard bookwork. Free and point load, full span UDL, couple, etc. Full bookworks. And then Friday I will tell you there is a shortcut method. Shortcut method. Remember, even for simply support also I have got shortcut method. That is, very sorry to tell, beyond your capacity. That shortcut I am applying for simply support beam, it is beyond your capacity. Very sorry to tell. Some will tell, oh what, you are knowing too much. Yes, I am knowing too much only. So that is beyond the capacity. But some of those shortcuts I will tell in the course for competitive examination, because some delicate points are there. But cantilever shortcut is universal. Cantilever shortcut, you don't have to solve. This question only I will solve by shortcut. But remember, the shortcut is applicable for maximum slope and deflection, and if you want for anything. So I will give you shortcut solution for cantilever on Friday. Friday cantilever will be closed. Next week I am starting new method. Moment area method and conjugate beam method. Not too much. Limitation is there. With the limited knowledge, important. Remember, that shortcut method I am going to take on Friday, and conjugate moment area method the coming week I am taking. They are very important for, anybody can tell? The shortcut I am going to tell on Friday and conjugate moment area method, they are very, very important for what? Anybody can tell? They are very important for, anybody can guess? No guessing. They are very, very important for. Okay, I will tell you are not answering. For competitive examinations. Okay. So then I will give a note there. Useful for competitive examination. Okay, now we got C1 equal to plus 1311.5 and C2 equal to, this is the value of C1 we got today, and C2 we got how much? Minus 7805.5. Okay, now I will finish everything required. See now, I told you maximum slope and maximum deflection both are at the free end. Don't tell left and right end. Okay, start. Okay, now this full I will remove. Start. One by one calculation. I will do one thing now. Little I will do. Remaining you have to do right now in the class and tell me got the answer. See. Because why? There is a limit. Deflection equation. Okay, start. Now, first they want to find maximum slope, that is called theta max, and maximum deflection, that is called y max. Okay, start. Make a note. This is the cantilever beam. See, This is the A, this is B. Beam will bend like this. Your Y max will be Y at B, free end. And even your theta max will be theta at B. That is both maximum at free end. Free end. Start. First. To get theta maximum, just now I told, theta maximum equal to theta at free end, that is theta B. Now, to get theta B, substitute, fast tell me, substitute x equal to, how much? Substitute x equal to, fast. To get, remember, our origin is here. Our x is going this way. See here, x is going this way. Substitute x equal to, fast, 0. X equal to 0 in slope equation. Start. EI into theta at the point B in clockwise equal to C1 is to plus 1311.5. That's all. Then minus 0, stop, plus minus 0, stop. Why? 0 minus 3 is not to be considered. Therefore, your theta B equal to 1311.5 by EI radian clockwise direction. Correct? See, it is clockwise. Now, equal to theta maximum. Over. Equal to theta maximum. This is the answer. Stop here if EI value is not known. But we know EI. So extend further. Therefore, you can tell theta max equal to 1311.5 divided by EI is 50,000 radian. That is, tell me in radian fast. After this one, next you have to do it. Other points you have to do it now. Tell me. That is radian, how much? How much radian? 0.2623 radian. 0.2623 radian, or that is, convert to degree, multiply by 180 divided by pi and tell me in degrees. I can see the answer there. I know the answer. I noted down the answer there. Degrees. Convert to degrees. A point not, okay. Point not, okay. 1 point, how much? Degrees, 1 point, fast, don't waste my time. Time is precious for me. 1 point, convert to degrees. Convert to degrees, this much time. That much radian, common man will understand if you give in degrees. Oh, what is this? This much time to convert that radian to degrees. 1.5029. 1.5029 degrees at the free end. Okay, start. Then, to get Y maximum, right, Y max will be Y at free end. Free end. That is YB. Now, to get YB, substitute x equal to 0 in deflection equation. Deflection equation. Start. EI y at the point B in upward direction equal to C1 into 0 is 0 plus C2 minus, it is C2, 7805.5, then minus 0, stop. Why? 0 minus 3 not considered. Therefore, your YB equal to 7805.5 divided by EI meter. Upward positive, negative came, that much downward itself is Y maximum. Stop here if EI is not known, but extend further, or Y max equal to 7805.5 divided by 50,000 meter. Tell me how much? How much meter? Point meter. Tell me in meter fast. Over. Last time asking you. Tell me in meter. I don't know what happened there. Some timed out. See that what happens, undo. When this calculator touches the pocket, some button it will activate, and see Sridhara Murthy was unhidden. And not unhidden anybody for 300 seconds. Ayyo, I never did it. I don't know what is the problem. I should not keep in pocket. 1 minute now. Here, put user in timeout, hide user. Ayyo. Sorry, I don't know why it happened. I should not put in the pocket. See, touch it there. Hide user in the channel. Put user in timeout. Remove. Report. I don't know what to do. Okay, leave it. Sorry. Somebody was actually timed unhidden. What is this? Okay, leave it. Next time I won't use it here. 0.15611. 0.156. 0.15611 meter, or you can tell 156.11 millimeter is the maximum deflection. Tell me. Fully clear means tell me. Over. I will go to next part. Maximum slope and deflection. Fully clear? Next tomorrow also same answer has to come. No change. Exactly same has to come tomorrow. Tell me. Full clear means now it is your turn to start. 156.11 millimeter. Full clear. I will tell you why. Fast. I have done unhidden. I don't know what is happening here. Next time I will not put in the pocket. Clear? Okay. Now do one thing. Now it is your turn to complete the question. Class will be there up to 9 o'clock. Right now you have type. You should type got all the answer, then leave the class. I will close the class at 9 o'clock. Okay, now start. What else I require? Now, to get slope and deflection at all standard points. Standard points. See, I will explain in the class. You should do it. I will explain in the class. You should do it. Okay, start one by one. Standard points are what? A, C, D, E and B. Actually B already over. That is theta max and y max. Don't do once again. Already over. At A don't waste time. Theta 0, y equal to 0. So A is already over. Now you need C, then you require D, then you require E. See correctly. For finding theta C or for finding yc, tell me what is the x value you have to substitute. For this one, x equal to find slope at C and deflection at C, tell me what x value you have to substitute. Fast. What x value you have to substitute. Tell me fast over. What x value you have to substitute to find slope and deflection at C. To decide what x value you have to substitute. This much time. To decide the x value for the point C. You are wasting time, see. Usual problem. Unnecessary wasting my time. I don't know what is the problem here. This much I have to wait for an x value. 6.5 meter. 6.5 meter you have to substitute. See, when you substitute 6.5 meter, see, this term will be 0. Other terms are there. I will tell you the answer. Your theta C will come 603 by EI radian clockwise. Deflection at C will come 489.2 375 by EI meter down. You first get this answer. After the class is over, substitute EI and get 0.6910 degrees, and this you get 9.7875 millimeter. Not now. After the class, you now get these two values over. To find slope and deflection at D, put x equal to 5 meters. See, at D. See, to find theta, use slope equation. To find deflection, use deflection equation. To find theta D and YD, substitute x equal to D, 5 meter. You substitute, you will get theta D 976.5 by EI radian clockwise, and deflection at D will come 1694.25. Suppose wrong, I will check once again tomorrow. 951, ayo, 1694.25 by EI meter down will come. After the class is over, substitute numerical EI, get 1.1190 degrees and deflection 33.885 millimeter. Later, not now. Now, lastly, to get slope at E and deflection at E, substitute x equal to, E is here 3 meter. 1 minute now. When you put x equal to 5 meter, these terms will not come. When you put x equal to 3 meter, this term also will not come. This will 0. Okay. You will get theta E equal to 1203.5 by EI radian clockwise, and deflection at E will come 3945. In case wrong, I will check once again tomorrow. Don't worry. You tell me wrong, but you type today only, getting all the values, I can forget tomorrow. Okay. This much meter down will come. After the class is over, substitute EI, get 1.4100 degrees. This will come 78.905 millimeter. Nobody can tell all these things, sir. These are fast. Clear? Tell me now. Now, still another, see, because I want involvement. It is not that question homework like that. I do not want mistake. Still another 5 minutes time is there. It is now 8:56. I will close the class exactly at 9:05. Why? I can take rest now. I will come and close at 9:05. By 9:05, that is nearly 10 minutes. Fast by checking. Later you can make fair copy. Now, fast substituting. Can you check all this value and let me know correct or not? Possible? Fast. Can you check all these values now and let me know in the comment box, correct or not? Okay, start. So, my work is over. Class will be on up to 9:05. That is, or 9:06, or another 10 minutes. Okay, now it is 9:07. 9:07. 9:07, I will come and silently close the class. Or before that, if I get message here, that what? Yes, everything came. Roughly do it. Fair copy you do later, after the class is over, not now. I want to know, is the value correct or not? Because tomorrow by alternate solution, same answer has to come. Okay, start. Okay, I will wait for 7-8 minutes and close the class. See you tomorrow. Don't log out now. Don't leave the class. Confirm and let me know answers are coming. Okay. One, two, theta E. Yes, I wrote 1230. Oh, it is a print mistake. Ayyo. Writing mistake. Actually, I also got 1230 only. You can make out, see, when you convert radian, you can check it. 1230.5. Actually, 1230 is there. If I put 1203, this value will not come. Okay. I told you, print mistake. 1203, 1230, interchange. Okay. Let me know all are coming or not. If all are coming, okay, you can leave. Okay, I'll close.